it's like a blanket on me, like for class. All right, so which variable looks easier to get alone here? 16.
X.
X in that top equation. Again, if you chose something other than X, this problem is just that much tougher. So 13 minus 3y. That now goes in place of X in the other equation. So negative 3 so that 9y and 2y become together to be 11y. This is 66. So then y ends up being 6. Again, once I know y, I can substitute that back in to find my x. So it's going to be 13 minus 3 times 6, so 13 minus 18. So that's going to be a negative 6.
What? Yeah.
Okay. Are we doing all of these, do you guys say finally? I think you said 17, 18, 19, 20. Yeah, all of them? Okay, that's fine. I just want to know before. Okay, so let me pull that up. Because we're learning a new method today, and I want to make sure you guys are comfortable with this one before we leave it. Now this one is a nice one because the R is already alone for us. That makes it a lot easier. So R is alone. So that automatically tells me what I'm replacing. Now careful your S's don't turn into 5s. So this becomes 24s minus 30 plus 9s equals 36. That's going to be 33s. So S ends up being 2. Once I know what S is, then I can substitute that back in to find my R. So 16 minus 10. So my R ends up being 6. Eighteen is another one that's already solved for us. 19 and 20 are definitely tougher problems. So I understand why those would go a little more poorly because of the fact that they're not as easy to solve by substitution. And today we're going to learn a method that kind of helps us with that. Okay.
Wow.
So now in 18, 30 solved for n. So I'm going to substitute that in place of n. So this is going to be 27n, and then that's 63. ends up being a -2. Again, once you know m, substitute that back in to find your n. There's our n value. Again, 18 and 19, or 19 and 20 were definitely tougher. And so again, if those were the ones you guys had issues with, it's totally understandable. They're definitely harder questions to solve by substitution. I personally, if I had my choice, wouldn't choose substitution, but they said to use substitution, so we follow the rules.
Unfortunately.
Now, I think there's one that looks easier than the other to get alone. So I think the bottom equation, getting x alone, looks easier, because dividing by 2 is better than dividing by 10, 4, or 6. Like, all those other numbers are a little bit bigger pains to divide by 2. So I'm gonna move this over. So I get 2x equals 10y minus 11, divide by 2. I have to divide everything by 2. So this is 5y minus, this will be 5.5. Not ideal, but not the end of the world. If you have a calculator, you can use that. So once we have that value, we have to take that and substitute it back in for x. And again, that's whole expressions going there. So I'm putting that back in for x. And when I do that, I distribute this 4 in. And I'm doing 4 times negative 5.5. That's going to be a negative 21.
What? I said 20y.
20y. No, well, that's 20y,
Oh,
but then,
you already did that one.
yeah, sorry. And then 22, I think. 5.5 times 2, or 4, sorry. Yeah, 22. Okay. Put these two together. So I get 26y. Move this back over. It's going to be a negative, or sorry, positive. What's that? 11? Is that right? No, 13. Sorry, I was like, that doesn't sound right. I can add 13. 5 by 26. So y ends up being 13 over 26, which is just a half. Not the worst answer in the world. So y is a half. Once I know y, then I can put it back in here to find my x. Half of 5.5 is 2.5 minus 5.5. So x is going to end up being negative 3. So a little bit bigger pain in that one. Not terrible. And then 20 likewise is tough, but still doable. Like, I wouldn't have given you guys like number 20 as a problem in algebra 1. But we're past algebra 1 now, so hopefully. I'm gonna write this one over here, because I'm gonna do that. So this one looks a little bit better. I like 3s and 4s better than 6s and 1s. So the reason for that is because I'd rather divide by 4 than I'd want to divide by like 6 or 1 or anything like that. So I'm gonna move this 3y over. And the reason why I want to divide by 4 is because 4 is divisible by 4, and I know 3 divided by 4 is 0.75. So I'm kind of doing a little bit of thinking ahead here. So dividing by 4, so I get 1 minus, and then you can make that 3/4, 4.75 y. Now once I have that, that has to go in place of x up here. Now, 0.75 times 6 is 4.5. So again, not ideal, but we have calculators for a reason. These two can go together. Move this 6 over. And I end it with 0.6 repeating, or that's gonna be 2/3. 0.6 repeating, or 0.67, 2/3. And once I have that, then I can put that back in up here. And I'm gonna multiply it the way it is. This ends up being 1 minus 0.5, so x ends up being 0.5. And again, when I multiply that back in, so I didn't have to do any rounding, I left this like crazy number in my calculator and just multiplied by 0.75. Go there. Right. The section title on the top is wrong. It should be section 3.2 again. Don't get it, you can pull that up.
Little issue.
It was funny when mom did it.
Yeah, I don't know where she thought it was so funny.
Your mom laughed.
Especially when she was like, "Hey, it's so funny, it's my daughter." I was like, "Mom."
She asked if you were adopted.
So it should be section 3.2. This is the second day of section 3.2. So like 3.2 part 2. If you haven't done so already, you guys can look at the warm-up question and kind of work through that. Do the numbers work out nice or are they bad? Bad.
She liked that.
All right, so not very nice numbers, and that's okay. That doesn't mean you did something wrong. It just means that So a little more work to do. So that goes in place of y. It's already solved for y for us, so we're gonna replace y with 5 minus 2x. Now you have to be careful here though. You need parentheses. So you have to distribute that negative in. And actually, if you don't, you end up with a lot nicer number, which would be nice, but not the case. So we have to distribute that negative in. So x and 2x can be 3x. And then I can move that 5 over. So I get 3x equals 14. And divide by 3 to find out x is going to be 4.6 repeating, 4.67. And then once you have that, then you have to substitute that back in to find our y value. 5 minus 2 times 4.67, or 14 over 3. And I think it's going to be like a 4.3-ish, negative 4.3, I think. Yeah, like negative 4.3 repeating, or just 4.33. Okay, so talking about what we've done so far, and we've done 3 different types. So we've done solving by graphing, solving by substitution, and today we're doing solving by linear or elimination. Some places you'll see they call it linear combinations. Now, if these are set up nicely, they're great. It's like a great method. If they're not set up nicely, it's kind of a bit of a pain. So if it's, if it's the right type of problem, these work out really nicely. So our elimination here, so this problem is set up really nicely. The biggest thing is to begin with, the equations should be lined up. So that's gonna be our first step. And what I mean by that, I should probably put that. So the x's are lined up, the y's are lined up, the constants are lined up. And so that's the case here. One of the things we want is we want something to cancel out. So I either want the x's to be the exact same number in the front and opposite signs, or the y's to be that way. I want one or the other to happen.
I remember this.
So in this case, if you guys look, I have the x's that are the same value but opposite signs. So they're nice and lined up and they're like kind of situated the way we want. So what we're gonna do is we're just gonna add these equations together. So we're gonna add the equations. Now, before we write our step 3, I'm gonna put a little asterisk in here. We we may need to multiply one or both equations to get this to happen. So you might have to change something about those equations to make that happen. So if that's not what we have here, you might have to do that. That asterisk should probably be with step 2, sorry. Once I have that, I'm going to add the equations. I'm going to add the like terms. So when I go to add these, the 4x minus 4x is going to cancel. And I have 8y and 2y are going to add together to be 10y. And 20 minus 30 is going to be negative 10.
Oh,
Able to add those together. And now I got my equation down to one equation with one unknown. So I can solve this new equation. So I'm just going to divide that by 10. So y is going to end up being negative 1. Once I know that, I still have to go back and find that other variable. So once I know y, I have to go back in and find our x. So I have to use substitution in this case. I'll substitute that y back in to find x. So we're going to find the other variable using substitution. So we're going to put that negative 1 back in and figure out what the y value is. Or sorry, the x value. I'm going to put this back in up here. We're solving them, and we find out that x has to be 7. That seem familiar to you guys now?
Yes.
Abby says so.
well, then it
And
must
Abby's
be-
always right. Yeah. That's your life motto.
So we'll flip to the other side. We'll do a few different examples back there. I'm probably going to alter things a little bit. I have an activity for us to do like on the mazes around room. I think we'll do that tomorrow, just with the number of questions we had on the homework for today. So I will I'll give us a break, but I'm going to, I'll definitely, I'm going to kind of change gears here a little bit. So I apologize if
We
you
correct?
guys have a shorter break. All right, so example 2, solving by elimination. Is everything lined up? Will something cancel if I add them? Yes. What's going to cancel this time?
Y.
The y's are going to cancel. If I add these two equations together, we have a negative y and a positive y, so those will cancel. So I'm left with 6x, and then also 12. 10 and 2. So that becomes a very simple equation for me to solve by dividing by 6. X is then 2. We'll substitute that back in to find our y value. can put it back into either of the two other equations. I usually try to find the one that is the simplest, and in this case, I avoided the one with negative values. So y ends up being 2 here. Now, that's the end of the ones that I consider very easy. I don't think the other ones get super tough, but this next one does not work the way the other ones did. What's the issue? You guys see it? What's wrong with this one?
Nothing cancels out.
Nothing cancels out. A -6 and a -6 don't cancel. 6 and 3 don't cancel. So we have to change one or both equations to make something cancel. So we have to decide, what do I want here to have something to cancel? What do you think, Brian?
You multiply all the equations by -1.
Yeah, it would be really good, yeah, because -1 is easy to work with. What Ryan's suggesting is what we want is we want one of those to be negative and one of them to be positive. I guess it doesn't really matter, but we want like a positive and negative 6x. So what Ryan's suggesting is why not multiply one of them by -1? That would change that sign. So we're gonna multiply, it doesn't matter, I guess I'll say the top one, by a -1. Does everyone understand how we chose that? Makes sense? So but we have to change everything, not just that value, you have to change the whole equation, otherwise it's no longer equivalent. This is gonna be a positive 6x, that top one, a -3y, and then a positive 12. So I just rewrote this equation down here. So good question. So the -1 came from the fact that this is what we wanted. We wanted to get those to cancel. And to change a -6 to a positive 6, you can just choose to multiply by -1. So we're picking a number that's strategic. So that's a way to get that value to change, and it has to be through multiplication or division. And we'll do other ones like this to make sure you guys got it. Because now the -6 and positive 6 are going to cancel. And then I have 6y minus 3y, that's going to be 3y. And then 6 and 12 is, you're just adding, so 18. I like to stick with adding rather than think about subtracting because it's really easy to mess something up in there. So I stick with the positive and negatives and always add them. So now we're ready to divide by 3. So y ends up being 6. Once I know y is 6, we can substitute that value back in to find the other variable. It doesn't matter which equation we put it back into as long as we stick it back into one of them. What do you guys want to put it back into? Matter? Love the 12? Sure. How about this one here? 6x minus 3 times 6. 12? X equals 30. All right, do you guys want to try number 4? See if you guys can do number 4. There's multiple ways to do that one. 2 times x. Oh yeah, I think you're good. Yeah, I think number 4 does have one of them as a fraction. Try number 4, please. And I think one of the variables is a fraction. It's probably the second one you're gonna find, but maybe not. No, it's fine. If you multiply by 4, yeah, this becomes a 36 and that becomes a negative 24. Yeah, that's fine. No, it's perfectly fine. I know the numbers get mixed sometimes. Multiply by -1? Yeah. And I think this should be a negative 15. Put negative 3 up. I think this one is just a little bit off. Not quite there. All right. So, do we have a preference on what we multiply by in this one? What do you guys multiply by? -1. The top one by -1. Did anyone multiply the bottom one by 4? Yeah, so I can show that over here as well. Make sure you guys got it. Alright, so this becomes a negative 4x, this becomes a negative 9y, this becomes a negative 9. We add those together, those cancel, or no, those don't cancel, sorry, too fast. Negative 3x, these cancel, this is a negative 15. So I'm going to divide by negative 3. Is this right? Did I do something wrong? Oh, it's positive 4. Ah, you guys stop me.
I was gonna say, I did not get that.
Okay, let's try this again. All right, sorry. So this should be a positive 4x, sorry, a negative 9, and a negative 9. There we go. This cancels. This is 5x. This is negative 15. And this is negative 3, is that right? Is that what you guys got?
Yeah.
Now I'm like doubting everything. Okay, so I get negative 3 for my x. Then I have to put that back in to find my y. And when I go to put that back in, this is where my decimal comes from, or my fraction. I get divide by 9, so I get y is negative 3 over 9, or a negative 1/3. I saw a few guys with a little bit different fractions, so check that. This one, I think Caitlin said she multiplied this one by 4. So this becomes 4x, this is 36y, this is negative 24. So this cancels. Here we end up with 45y, and this is a negative 15. So y ends up being negative 15 over 45, which is a negative 1/3. The good news is when you put this back in, either one, it works out to be a nice number. So negative 4x plus 9 times negative 1/3 equals 9. Negative 1/3 of 9 is just a negative 3. So negative 4x equals 12, and then divide. All right. I'm gonna take notes for a while. It's not raining anymore. Do you guys wanna go outside just for a bit?
Yes.
So,
I need to get up and move. Otherwise
Yeah,
I'm gonna fall
I know,
asleep.
I'm afraid that I'm losing some of you guys. So we're gonna take a break.
I'm keeping the ball cabins.